You know, in a time when we can watch live video from space and carry a map of the entire globe right in our pockets, one of the oldest questions in history is making a really surprising comeback. What is the actual shape of our world?
So that raises the big question we're going to look at. In this age, an age that's so defined by scientific discovery, why is this idea getting so much attention right now? Let's dig in. To guide us through this, we'll be looking at a book called Flat Earth Uncovered. It carefully goes through 100 of the most common questions that really bring this debate to life, giving us a pretty clear window into the arguments and the thinking behind the movement.
All right, so to really get a handle on this whole debate, we first need to understand the model that's being proposed. What exactly is the flat world theory?
Well, this here shows the fundamental differences. Instead of a sphere, the flat world model suggests a disk. Instead of endless space, there's a boundary, an ice wall, which is what we call Antarctica. And in this view, the sun isn't some distant star, but it's a much smaller, closer spotlight that circles above us.
This illustration from the cover of the book gives us a really clear visual. You can see the continents laid out on a flat plane with the sun and moon circling overhead, all of it contained inside that outer ice wall.
Now, a really central idea in this model is something called the firmament. This comes from interpretations of ancient texts, and it's described as a solid, physical dome that actually encloses the world. This dome is believed to hold the sun, the moon, and the stars, creating a sort of self-contained system.
And this model is what leads us right to the heart of the disagreement: observational evidence. This is really where what people see with their own eyes seems to clash with what established science says. A lot of the time, the argument for a flat world starts with a very simple, direct question based on what anyone can see for themselves. Why does the horizon always look perfectly flat? And this is where you see two completely different ways of interpreting the exact same observation. The flat world argument is straightforward. You see a flat line because you're standing on a flat plane. Mainstream science, on the other hand, explains that our world is just so enormous that its curvature is far too subtle to be seen from the ground.
And this brings up another big observational puzzle. How is it possible to see buildings or landforms from distances where, in theory, the curve of the Earth should be hiding them from view?
And here we are again with the same observation leading to two totally different conclusions. For some, seeing these distant objects is direct proof of a flat surface. The scientific explanation, however, points to something called atmospheric refraction, where light actually bends over long distances, creating a kind of mirage.
So, we've seen how physical evidence is interpreted, but if those observations are seen as correct, it would imply a cover-up on a global scale. And that leads to the massive question, why? Why would anyone hide the world's true shape? This is where the whole debate moves from physics into the realm of conspiracy.
The core belief here is that a deception of incredible scale is underway. The theory puts forward that a network of powerful institutions is actively working in concert to hide the truth from all of us.
So who is said to be part of this conspiracy? Well, according to the theory, it's a huge operation. It involves government space agencies like NASA, the entire scientific establishment, our educational systems that teach the globe model, and of course the media that reinforces it. But this isn't just about the shape of the world. This book, Flat Earth Uncovered, actually frames the movement this way. Quote, as a symptom of a larger trend of questioning authority, mistrusting institutions, and seeking answers outside the mainstream.
And that brings us to the psychology of belief. What makes this worldview so compelling for people who subscribe to it? It seems to be about a lot more than just the physical evidence.
You know, the path into this belief system often follows a pretty recognizable pattern. It usually starts with just a little seed of distrust in mainstream science or government. Then online communities and algorithms can create these really powerful echo chambers that reinforce those initial doubts. But it isn't just about information, it's also about connection. These groups can offer a really strong sense of community and a shared purpose. And honestly, in a world full of complex science, this model can provide a sense of certainty, a simple and intuitive way to understand the world around us.
So, after looking at the model, the evidence, and the motivations, what's the big takeaway here? What does this modern debate really show us? When it comes right down to it, this whole debate isn't really about geography. It's a fascinating look into the information age we're all living in. And that leaves us with one final, big question to think about. What does the return of an idea like this really tell us about our modern relationship with information, our trust in authority, and our search for what is true in an incredibly complex world?
Questions shape understanding. Questions guide discovery. And the right question can change how you see the world. This book offers many worth considering. Click the link to get your copy of Flat Earth Uncovered, 100 Questions That Challenge the Round Earth by Sue B. West.